Welcome to the video lesson for converting into intercept form. Let's go ahead and get started. We talked about this a little bit in class the other day, but currently we have an equation that is in what we call standard form. In order to convert it into intercept form, what we're going to do is we're going to factor our initial equation. In order to factor, we're going to use our butterfly method. So I'm going to go ahead and write down the factors of x squared, which would just be 1 and 1. And then we'll write down the factors of negative 12. And I know they have to add to be a positive 4. So I'm going to go ahead and put a 6 and a negative 2. And then when we do our check, when we cross multiply, we get 6 minus 2, which is equal to 4. And it's, equal to 4. And it's supposed to, so we know we're good, which means I can now factor this as x plus 6 and x minus 2. And we have a y equals at the beginning. So that is now our equation in intercept form. In order to find the x-intercepts, as we discussed in class, we're going to take each one of our factors and set them equal to 0. So I have x plus 6 is equal to 0. And then we also have x minus 2 is equal to 0. And then when we solve each one of these, we get our x-intercepts, which would be negative 6 and positive 2. When we look for our y-intercept, again, the y-intercept, as we discussed in class, means that x is going to be 0. So I'm going to plug in a 0, and I'm looking at my original equation here. We get 0 squared plus 4 times 0 minus 12, which means that my y-intercept is going to be y is equal to negative 12. So something that we can kind of connect here, when we have an equation in standard form, that constant term that's at the end is always going to be our y-intercept. So if we have it in that form, we'll at least have some initial information given to us. We're going to go ahead and graph this. We're going to start by graphing our x-intercepts. Again, I have an x-intercept at negative 6, and then at positive 2. And then we talked about this idea of finding our vertex by looking at what is called the middle, or the value in between. So then we would have x is equal to negative 6 plus 2 over 2, which ends up being a negative 2. So I know that the x portion of my vertex is negative 2. To find the y portion, I'm going to take my value. I'm going to take that negative 2, and I can plug it into either the factored form or the original equation. I always prefer the original equation because we could have made a mistake when we're factoring. So we're going to go ahead and plug it into that original equation, and we're going to get y is equal to negative 2 squared plus 4 times negative 2 minus 12, which is equal to a negative 16. And so unfortunately, this goes a little bit off of our chart here. I'm going to go ahead and kind of approximate where it's going to be. We know it's at negative 2. I'm going to go down here to about where negative 16 might be. And we're going to go ahead and connect our dots, and that would now be the graph of our parabola. When we look at example 2, this is another equation that we need to put into intercept form by factoring it. But we notice that our first term is a negative x squared. In order to factor it using our butterfly method, we need to have a positive value. And it's always helpful if we have a positive 1. So what we're going to end up doing is we're going to go ahead and take out a negative 1 here. Now something I hope that you recognize is that this is the difference of squares. We have x squared and 9 is the same as 3 squared. So we can apply our difference of squares process here. If you've forgotten that, we can go ahead and do the butterfly method, which would be, again, a 1 and a 1. And then we have a 3 and a negative 3. And when we cross multiply and add them, we have 3 minus 3, which is equal to 0. And it's supposed to be 0 because we have no x term. So now this is correct, which means that my factored form would be a negative 1 times x minus 3 times x plus 3. And again, we notice that we have a difference of squares, which you can factor using our process, if you guys do remember that. We're going to go ahead and find the x-intercepts, same way as we normally do. We're going to take our factors, and we're going to set them equal to 0. And we solve, we get x is equal to 3, and x is equal to negative 3. To find our y-intercept, once again, we're going to go ahead and plug in 0, and I like to plug it into the original equation. So for my y-intercept, we have y is equal to a negative 0 squared plus 9, which means we get just 9. And we notice again, it was in standard form to begin with. This value here is our y-intercept. So we have 3 points now. I have my 2 x-intercepts. I'm going to go ahead and graph those. We have one at negative 3, one at positive 3. I know that my y-intercept is at 9. And I notice that this looks like it's going to be facing down. Just to double check, I have a negative. Regardless of which form I'm looking at, I have a negative a value, which does tell me it does, in fact, go down. The last thing we're going to do is verify our vertex. To find that vertex, we're going to find the middle term for our x-intercept. So we have x is equal to a -3 plus a +3 over 2, which gets us x is equal to 0. And conveniently, when x is equal to 0, we already know y is equal to 9. So in this case, our y-intercept is our vertex, which means we don't have to do any additional work. We can just go ahead and sketch our graph. We're going to go through our points, and that would be our parabola. All right, I would like for you guys to go ahead and try the your turn. What I want you to do first is factor out the GCF. And after you factor out the GCF, try and apply the butterfly method to finish factoring that 2x squared minus 4x minus 6, and then check back in and see how you did. All right, hopefully you guys got the same thing that I got. I took out a GCF of 2, and then I had x squared minus 2x minus 3. From there, I went ahead and applied the butterfly method, and I had a 1 and a 1 for my x squared, and then a -3 and a 1 for my constant. When I cross-multiplied and checked, I did get a -2, which is what we want it to be, so I know we're correct, which means that my factored form is 2 times x minus 3 times x plus 1. When we go ahead and find our x-intercepts, again, we take those factors and we set them equal to 0. So we get x is equal to 3, and then we also have x plus 1 equals 0, which gives me x is equal to -1. Okay, go ahead and find the y-intercept and then attempt to graph this and check back in and see how you did. All right, so you can see once again, when we plug in a 0 for our x value into our original standard form, we do get that constant value of -6 that we started with. You again would have got the same answer if you plugged it into the factored form. Regardless, your y-intercept is -6. To find the vertex, I wanted to find the mid value between my two x-intercepts. So I had +3 plus a -1 divided by 2, which is 1. I then took that 1 and I plugged it into the original equation because I want to make sure I'm using the one that I didn't make mistakes on. And I got for my y value a -8, which gives me that vertex again, just to correspond those two values together. Your vertex is going to be the point 1 and -8. I then graphed all of my points. You can see that I graphed my two x-intercepts at -1 and at +3. I then graphed my y-intercept down here at -6, and I graphed my vertex of 1 and -8, and I connected all of my dots. All right, that does it for our notes. Go ahead and work on the practice problems, and good luck.